Welcome to my channel Mathematical Clinic of Subhasja. Friends, if you have not subscribed my channel, please subscribe it. Today we are going to discuss the topic limits and continuity. This one is the very important topic of mathematics, and the topic begins with approaching value. So first of all, let us discuss the word approaching value. What the approaching value is. Uh, I'm going to write here some number. First number is 2.999. Can you say that 2.999 is very close to 3? Of course, it is very close to 3. Another number I am going to write is 3.001. Does 3.001 very close to 3? Of course, it is also very close to 3. Can we say 2.6 is close to 3? Maybe. And 3.4 is close to 3, maybe close to 3, may not be close to 3. When we can say that 2.999 is the approaching value of 3? Actually, this number is very close to 3. In the junior level, we studied approximation. While approximating, we wrote 2.99 equal to 3. But this approaching value is a little bit different than the approximation one. We all know that this 3 is not equal to 2.999. But if you are writing 3 in place of 2.999, then you are neglecting something. That thing you are neglecting is called error. And error can be calculated by subtracting this number from this number 1. If you subtract 2.999 from 3, then the result will be 0 decimal perhaps 0001. So if 2.999 is written as 3, then 0.0001 is the error. Of course, this number is not equal to this. But if you are writing if you are writing 3 instead of 2.999, then you are neglecting this number 1. This number is meaningless for you in that case 1. Now the matter is number this negligible? For example, if you are going to bring 3 kg potato, and shopkeeper gives you 2.999 kg potato, then it's all right, because 0.0001 kg potato is worthless. But if you are counting hydrogen atom, for example, you are counting a hydrogen atom in 3 gram hydrogen, but instead of 3 gram you are counting in 2.999 gram hydrogen, then the difference, this error is this much gram hydrogen contains almost crore of hydrogen atoms. So in that case, this error is not negligible. If this error is negligible, those cases in which this error is negligible, really negligible, in that case this 3 is called the approaching value of 2.999. But error is not negligible, then this one is just the approximate value rather than the approaching value one. Similar thing applies here. If you are writing 3.0001 as 3, then the error is again subtract this from this or this from this. If you subtracting 3 from 0.001, then the result is 0.001. This one is the error. If this one is really negligible, then this number 3 is called the approaching value of this number 1. But if not negligible, then simply the approximate value. That is the main thing of approaching value 1. Actually, if error is negligible while writing one number to another number, if we are writing in general, if we are writing x as a, then the error of x and a is x minus a, and error is never negatively calculated. It may be negative, so let us make it positive by taking absolute value here. So absolute value of x minus a means error of x and a. If this is negligible one, then a is the approaching value of x, otherwise not. So in simple, in summary, we can say that a real number a is the approaching value of the real number x if the error of x minus a, that is the modulus of x minus a, is negligible. That I'm going to write here. Real number a is said to be approaching value of x if error of x minus a means modulus of x minus a is negligible. I think you have got the matter. Uh, means a real number a is the approaching value of another real number x. If the error of these two, it means the positive difference of x and a is always negligible. Now I am going to add something here. In mathematics, epsilon and delta represents sufficiently small. Sufficiently small. Maybe this one, the decimal 10, 20, 0 thereafter one. Sufficiently small but positive real number. This one is positive. Sufficiently small. This one is negligible. However, positive negligible real number. Once again, I am going to tell you, in mathematics, if anywhere epsilon and delta comes, then we have to uh, think that this one is sufficiently small positive real number. Can you say that this one is negligible? Yes, this one is negligible. Now, this number itself is negligible. And if this number, error of x minus a, modulus of x minus a is the error of x minus a, this number is even smaller than this number 1, smaller than this number, suppose delta. This number itself is negligible. And then this number is, error of x and a is the smaller than delta 1. If this one is negligible, then this one is surely negligible. So rather than writing modulus of x minus a is negligible, we could even write modulus of x minus a is less than delta. So the original definition of approaching value is a real number a is said to be approaching value of a real number x if for sufficiently small positive real number delta. Delta is sufficiently small positive real number, almost a negligible real number. The error x minus a, modulus of x minus a, the error of x minus a is smaller than delta. To say the error of x and a is negligible, or to say modulus of x minus a is less than delta, is similar thing, same thing. Here, rather than in word, we have described the thing mathematically. So we know that approaching value is denoted by x approaches to a or x tends to a. This one is read as x approaches to a or x tends to a, or we can say that a is the approaching value of f. This one is the symbol of approaching value 1. We can say that x approaches to a or x tends to a or a is the approaching value of x, and to happen this result must hold. So in summary, we can say that x approaches to a if and only if modulus of x minus a is less than delta for sufficiently small positive real number delta 1, this type of delta 1. Getting it? Now we are going to discuss some interesting thing about this factor 1, this mathematical factor 1, error is less than delta, error is negligible. To study that, we will use a theory of set theory, formula of set theory. That formula 1 is, if modulus of any number is smaller, we will study this theorem, this formula in set theory. Here we are going to use, if modulus of x is smaller than a, then if you remove the modulus, this number's negative number must be kept here. So this result can be replaced by minus a is less than x is less than a. Here similar result is there. Modulus of x minus a is less than delta. Similar thing is there. In place of x, it is x minus a. Let us apply same mechanism here. it becomes, if you remove modulus, then it becomes x minus a less than delta as it is. Here you will have to write the negative of this value 1 minus delta. Getting it? Once again, concentrate here. Modulus of x is smaller than a, then the negative of a must be written on the left, a as it is, and in middle the modulus sign should be removed. Same thing has been applied here. Here also modulus of x minus a is less than delta, so negative of delta has been kept here, delta as it is, and modulus is removed from the middle. I am going to add a small a in all these terms. If you add a small a here, then it becomes a minus delta. This one becomes x minus a plus a will be cancelled, you will be left with x, and this term will be a plus delta. Now let us think this result, see this result in real line. Everybody know about the real line? Real line is a geometrical representation of all the real numbers. The left termination of real line is minus infinity, right termination of real line is plus infinity. Because a real line does not terminate, these infinity and minus infinity do not exist. Now suppose this one is the point x. In real line you can see, look here, suppose this one is the real line, here is 0, here is 1, here is 2. We can say that a smaller number, 1 is smaller than 2, so 1 is in the left of 2. If 3 is bigger than 2, then 3 must be on the right of 2. Getting it? So a smaller number are on the left and bigger number are on the right. We have taken x here. Suppose x is a real number situated here in the real line. So where does, suppose this one is the number a rather than x. A is the real number situated here. So where does a minus delta lie? A minus delta is smaller than a. So a smaller number, 1 is smaller than 2. So 1 is in the left of 2. Here a minus delta is smaller than a. So a minus delta must be on the left of a small a1. By this similar manner, a plus delta is bigger than a, and bigger number is always on the right. 3 is bigger than 2, then 3 is on the right of 2. So this a plus delta will be on the right of a. We are able to say that a number x approaches to a if x lies between these two. Lies between these two means x must be from here to here. X must lie here. If x lies between a minus delta and a plus delta, then a is called the approaching value of x. So we can say that a is the approaching value of x. In other words, we can say that x approaches to a if and only if this x lies between a minus delta to a plus delta. Getting it? Once again I am going to tell you from the beginning. We learned that x approaches to a if and only if this result hold, either is negligible or modulus of x minus a is less than delta. To say either is negligible or to say modulus of x minus delta is similar thing. So the definition of x approaches to a is a real number x is said to approaches to a if and only if modulus of x minus a is less than delta. I am going to derive some important result from this result one. So I have simplified this one. Here modulus of x minus a is less than delta written as it is. I have applied a theory of set theory here. The theory one is, we will study this theory in the set theory one. If modulus of x is smaller than a, then to remove the modulus, if you remove the modulus, write simply x, then the negative of this number must be kept in the left. This is the theory. I have applied that theory here. We have removed modulus from this term, so it is x minus a. That is why the negative of this delta is kept here. I have simply simplified it, added a small a to all of them. If you add a small a to this number, then it becomes a minus delta. If you add a small a here, then a will be cancelled, you will be left with simply x. If you add a to this term, then it becomes a plus delta. So we came to the conclusion that x approaches to a if x lies between a minus delta to a plus delta. We have noticed this thing in the real line. We have taken a small a here because a minus delta is smaller than a minus delta is on the left of a, and a plus delta is bigger than a, that is why a plus delta is on the right of a. So finally we come to the conclusion that x approaches to a if x lies between a minus delta to a plus delta. That is written here. Now I am going to uh, you know, uh, write x approaches to a in two manner. Actually, we learned that x approaches to a if x lies from here to here. I am going to divide this interval from this point to this point in two groups. First group one is this one, and second group is this one. This group means x lies from a minus delta to a, and this part means x lies from a to a plus delta. Everybody concentrate here. If x lies, if x lies in this part of x lies between a minus delta to a, then if x lies in this part one, then also is the approaching value of x. But this type of approaching value is called the left approaching value, and written as x approaches to a minus. This one is the symbol of left approaching value. This is the left approaching value. There are two types of approaching value now: left approaching value and right approaching value. If x lies in this part one, it means the x is smaller than a. This type of result. Here, this one is x, and x1 is the smaller than a. This one is x, and x is the smaller than a. Then this limit one is this approaching value one is called the left approaching value of this one. So if the number is smaller than x and approaches to x, then that x is called the left approaching value of the given number one, or a is called the left approaching value of the given x1. But if x is bigger than a, x is bigger than a means x lies from a to a plus delta. If x lies between a to a plus delta, then also x approaches to a, and that approaching value one is called the right approaching value of x. So there are two types of approaching value: left approaching value and right approaching value. The symbol of left approaching value one is x tends to a minus, and symbol of right approaching value one is x tends to a plus. X approaches to a from left if x lies in the first half one. First half means a minus delta to a. X approaches to a plus. A plus means a is the right approaching value of x if and only if this x lies on the right part one. Right part means a to a plus delta one. So friends, we must concentrate that first of all what the approaching value is. Approaching value, a is the approaching value, a is the approaching value of x if either of x and a is negligible. That is written firstly. Either of x and a is the positive difference of x minus a. Positive difference of x minus a is called the either of x and a. If this one is negligible, if this one comes like this, and this one is negligible, then a is called the approaching value of x. In the next step one, we have described that particular matter mathematically. We learned that delta is the sufficiently small positive real number. For example, delta is, we have written here, delta may be like 0 decimal 0 0 0 0 0 20 30 0 thereafter 1. This one is sufficiently small, almost negligible in all the cases. Delta is this type of number, but positive number. This one is negligible. Delta itself is negligible, but here we have written our error even smaller than that negligible number. So surely negligible. So rather than writing modulus of x minus a is negligible, modulus of x minus a is negligible, we can write modulus of x minus a is less than delta. So we learned that a is the approaching value of x if modulus of x minus a is less than delta. This one is the definition of approaching value 1. If the definition will come in the examination, then you will have to write this one. A real number a is called approaching value of real number x if for sufficiently small positive real number delta modulus of x minus a is less than delta. This one is the definition of approaching value. Thereafter, we have studied this thing geometrically. To study it geometrically, we have applied this theory of set theory. If modulus of x is smaller than a, then x lies between minus a and a. This one is the theory we will study in set theory 1. But here we have applied. Modulus of x minus a is less than delta. That is why remove modulus and minus delta is written here. We have simplified it, added a to all the terms, and come to the conclusion that a minus delta is smaller than x is smaller than a plus delta. We have presented this result on the real line geometrically. Suppose this number is a, then a minus delta will be here on the left of a plus delta will be here on the right of a. So if x lies from this point to this point 1, from this point to this point 1, only then x approaches to a. That I have written here, x approaches to a if and only if x lies between a minus delta to a plus delta. That is written here. Thereafter, we have classified approaching value into two groups. Left approaching value, this one is the symbol of left approaching value, and this one is the symbol of right approaching value. Left approaching value is the left approaching value of x if x lie in this part 1 from a minus delta to x, and x is the right approaching is the right approaching value of x if that x lies from a to a plus delta. Thank you very much. On our second video, we are going to discuss the word in infinity and indeterminate form. Continue watching.